Everyone in pharmacy knows that children are not just small adults. Their organ systems work differently, their body composition is different, and yes, depending on age, they are usually smaller than adults. These differences demand a completely different way of deciding medication doses. One size does not fit all. Pediatric doses are based on body weight, or body surface area. Pediatricians are likely to order drugs for children as a milligram per kilogram dose, and the expectation is that the pharmacist will make the calculation. Pharmacists and technicians who have not been trained in pediatric pharmacy are at a greater risk of making decimal point errors when making these calculations. It is the job of everyone in pharmacy to assure that every patient receives the appropriate medication, so technicians need to be familiar with how to do a pediatric dosage calculation so they can provide needed double checks. A few years ago, a small for his age 3-year-old child was due to have a test to see if he was producing adequate growth hormone. The pediatrician ordered arginine 0.5 grams per kilogram of body weight to be infused for the study. Since it was an outpatient test, the family was to obtain the medication from an outpatient retail pharmacy and take it to the testing center. Arginine is supplied as a 10 gram per 100 milliliter solution in 300 milliliter bottles. The boy weighed 24 pounds. If the little boy was to get 0.5 grams per kilogram, what was the dose needed for the test? When we solve a problem like this, first we look at the units in the problem. In the problem, the boy's weight is listed in pounds, but in order to solve the problem, we need to know his weight in kilograms. Therefore, the first step is to convert the child's weight to kilograms. 1 kilogram equals 2.2 pounds, or 1 kilogram per 2.2 pounds. 1 kilogram per 2.2 pounds times 24 pounds equals 10.9 kilograms, which we will round to 11 kilograms. Now that we know the child's weight in kilograms, we can calculate his dose. A dose written as milligrams or grams of medication per kilogram of weight is a ratio that says, for every kilogram of body weight for this patient, administer X amount of medication. If the ratio says the dose is 0.5 grams per kilogram, then we know that for every kilogram of body weight, the patient gets 0.5 grams of medication. We know that the patient weighs 11 kilograms, so 0.5 grams per kilogram times 11 kilograms equals 5.5 grams of arginine needed for the test. Now we need to answer the question, how much arginine solution contains 5.5 grams? The problem above states that arginine injection is supplied in a solution that contains arginine 10 grams per 100 milliliters in 300 milliliter bottles. Right away we see that 100 milliliters of solution contains 10 grams, which is more than the required dose, so much less than one bottle is needed for the test. To determine the exact volume needed, set up a proportion equation. 10 grams per 100 milliliters equals 5.5 grams over X, where X is the volume that contains the 5.5 gram dose. To solve a proportion equation, the numerator on the left multiplies the denominator on the right to form one side of the equation. Then the numerator on the right multiplies the denominator on the left to form the other side of the equation. 10 grams times X equals 5.5 grams times 100 milliliters. Now we solve for X. Remember, when solving an algebraic equation, whenever a mathematical operation is performed on one side of the equation, the same operation must be performed on the other. Our goal is to isolate the unknown, X, so we will divide both sides of the equation by 10 grams. X equals 0.55 times 100 milliliters. X equals 55 milliliters. Sadly, The little boy in the real case received 600 milliliters of arginine, or 2 large IV bottles, about a 10-fold dosing error. He slipped into a coma from the overdose and died. When working with pharmacy math problems, always ask yourself, does this answer make sense? If the answer to the problem calls for multiple IV bags or bottles or multiple tablets or vials, then no, it probably does not make sense. Take the extra time and care to double check. Someone's life may depend on you. This is a sample of a dosing problem that can be found in the ASHP textbook, Pharmacy Calculations, and Introduction for Pharmacy Technicians. For more information, visit www.ashp.org/techcalculations.